go. Hello, everybody. My name is Matthew Powers, and we are chatting about Pandas on Spark today. Pandas on Spark is a really cool API. It provides the simplicity of Pandas and the efficiency of Spark. So my co-presenter here is Xinrong Mei, and I will give her the stage so she can introduce herself.
Hi, everyone. I'm Xinrong, and I work at Databricks as a senior software engineer. And I'm also a PMC member and committer of Apache Spark. I'm one of the main contributors of Pandas on Spark, and I'm really excited to be here. Yeah, thanks, Matthew.
Yeah, of course. Yeah, so I'm Matthew Powers. I'm a developer advocate at Databricks. I'm a long-term Spark and Delta Lake blogger. I've also contributed to both open source projects. I'm going to give a high level of Pandas on Spark, and we're lucky to have Xinrong here to answer all of your questions. She has been in the weeds on the project and knows all the dirty details. Cool. What are we going to chat about today? We're going to talk about what is Pandas on Spark at a high level, how do you use it? We'll talk about how it works, like the underpinnings of the technology. Then we'll talk about how to go beyond Pandas with Pandas on Spark. And if we have time, we'll chat about what's new. So let's start out with a simple example. So this example is going to run on a 3-node cluster. Each node has 64 gigs of RAM and 8 cores. So here we have a 48 gig Parquet dataset. And when we're using Pandas and we try to read this in, we can see we get this out of memory error. Anybody who's used Pandas knows all about this. Now, with Pandas on Spark, we can use the same exact syntax. All we're doing is changing up the import statement a little bit. We can see that we're able to read in this data set no problem. So this kind of very quickly shows the magic of Pandas on Spark. You can use this familiar Pandas syntax and execute your queries, no problem. Let's take a look at an intro of this technology. So Pandas on Spark sits at the intersection of Spark and Pandas. So Spark is this big data distributed query execution framework. And Pandas is a single node, single core data frame tabular analysis technology. And Pandas on Spark kind of gives the syntax of Pandas, but the execution power of Spark. So Spark is, as everybody knows at this conference, de facto engine for big data analysis. It is integrated across a lot of different ecosystems, and it can work on a single node or a computation cluster. Now, Pandas is also very popular in the data ecosystem, but it's only good for single node analysis and only uses a single core. Now, we still love Pandas because it's so well integrated in the data ecosystem and it's so interoperable with so many different libraries. So Pandas on Spark, as we've discussed, provides the syntax of Pandas, but the execution of Spark. It was originally introduced in 2019 as koalas, and then in 2021, it was integrated into the Spark codebase itself, and that's when it was renamed to Pandas on Spark. So let's look at the different ways to scale at a high level, and then kind of see how Pandas on Spark actually executes queries. So there's a couple different ways to scale. One is to, instead of using one core, you can use all of the cores of a machine and kind of stream in the data and process the data as you go. So that's one way to scale. Another way to scale is to just use a bigger computer, right? So if we have, let's say 64 gigs of RAM locally, and it's not enough compute power, maybe you just use a bigger cloud machine to run your Pandas analysis. The third way to scale is to scale out to many different computers. That's kind of the Spark way of scaling, right? We distribute a data set to many different clusters in a node. And the fourth way to scale is kind of the cheating way to scale, which is just take a subset of the data. Of course, we're sacrificing computational accuracy if we're just taking a subset of the data. I think lots of Pandas users have to revert to that frequently. Like if they are suffering from an out-of-memory exception, they just kind of have to take a subset of their data rather than analyze all of it. But that, of course, sacrifices computational accuracy. So, what is Pandas on Spark? It allows you to write your Spark code with Pandas syntax, which is great if you're familiar with Pandas syntax. It's going to perform just like PySpark or Scala Spark or SQL, Spark SQL. So from a performance perspective, it's pretty on parity with the other language APIs. It's great for users that like Pandas syntax. So if you like Pandas syntax, this is a great option. Of course, if you love PySpark syntax, you don't have to use this. And one kind of thing that's cool about Pandas on Spark is it can be used in conjunction with regular Pandas. So I think this isn't an either-or choice. You can use both technologies. We're actually going to talk about that later and give an example. For a large data set, Pandas on Spark will generally be faster. Okay, let's look at a query on a large data set using Pandas on Spark. So here we are reading in a table, and we can see that that is 7.1 billion rows of data, and it's around like 210 gigs of data. So there we're using Pandas on Spark to read in the table, cherry pick a few of those columns. Then we're running a filtering query followed by a group by aggregation. We can see that this computation runs in, well, it's a little hard to see because of their subtitles. This computation runs in, I think it's 11.4 seconds. So we're using Pandas syntax. We're querying a pretty big data set, and we're able to query our data in only 11.4 seconds. So the performance is very good. So now let's juxtapose the Pandas and PySpark syntax and kind of show why transitioning from Pandas to PySpark can be a little difficult for somebody who's really familiar with Pandas. So on the left-hand side, we have this Pandas query. What we're doing is reading a Parquet file, and then we're running some filtering logic, and that's about it. It's a pretty simple query. Now, if we look at the equivalent PySpark syntax on the right, we can see that the PySpark syntax is similar, and it's actually really nice and clean, but it's clear that this is different, right? The PySpark syntax is quite different from Pandas. Now, if you're familiar with Pandas syntax and don't feel like learning a new syntax, you might say, well, PySpark seems a little scary. I don't necessarily want to learn that. So here in this slide, we can juxtapose the Pandas and Pandas on Spark syntax and see how Pandas on Spark is such a nicer transition, so much easier. So on the left, we have that same Pandas filtering logic that we saw on the previous slide. And on the right, we can see the Pandas on Spark syntax. And there we can see all we're doing is changing the import statement. And other than that, the syntax is the same. So Pandas on Spark is a really easy way to get into distributed computing and scaling to large data sets for Pandas users who want to stick with their familiar syntax. Let's take a look at a query on a single node analysis. I ran this on my local machine. And this is on a billion row data set, which is around 31 gigs when stored in a Parquet file. And my machine is a 2020 MacBook M1 with 64 gigs of RAM. So we have this little Parquet file with 9 columns of data. We're going to run a query with the Pandas engine. So you can turn your attention to section 2 there. And we can see we're going to use that read Parquet method. We're going to specify the file path. We're going to specify the columns to use for this query, along with the row group filtering predicates. And after we read in the data, we are going to run a query with some filtering logic and then a group by sum aggregation. We can see that that takes 275 seconds to execute with Pandas locally. And if you don't specify those columns and filters arguments, this actually didn't work on my computer. It blew up with the out-of-memory exception. Now let's run this equivalent query with Pandas on Spark. And there we can see we're using very similar syntax, although it's a little more simplistic. I guess I should have made my slides a little bit more vertical. Let me see if I can adjust that a little bit so it's visible. Anyways, so we're using very similar syntax. But we don't have to specify the columns or the filters because Spark has an optimization engine. So Spark can optimize the query so the user doesn't need to manually specify those arguments. Now that query can run much faster. I think it was around 60 seconds. And part of the reason why I made this slide is just because I wanted to show how even on a single node, you can get a really nice speed up with Pandas on Spark. Now, the big caveat there is that Pandas on Spark is not going to always provide a nice speed up. Like if it's a tiny data set, Pandas might be faster. But in this example, we can see that even on a single node analysis, it can provide a really nice speed up. Okay, cool. So let's take a look at, let me actually see if I can adjust these slides. So can we make that a little bit more vertical, you think, Shinrong? Anyways, maybe not. Let's take a look at why some manual pandas optimizations can be a bit dangerous. So in the previous slide, we talked about how I tried to run a query with pandas. It wasn't working. It was out of memory exceptioning. So we had to specify those columns and filters arguments to read in less data into memory so we could actually run our query. So now let's take a look at a situation where we're running these manual optimizations and they're incorrect. And because they're incorrect, the pandas query is going to be incorrect. So we have this Parquet file with 9 rows of data. And in section 2 there, we can see we have our nice Pandas on Spark syntax, which runs the query, no problem. And then in section 3, we can see we're actually using this Pandas syntax, and we're specifying the filters argument, and it's incorrect. And since those filters are wrong, the query is going to return the wrong result. So that's kind of a little dangerous, and it's something I didn't even realize until I was making this presentation. But when you're forcing users to perform these manual optimizations, they can perform them incorrectly, which would give the wrong result. Cool. All right. Now let's take a look at how we can easily convert from Pandas on Spark to Pandas data frames and why this is really useful in certain production use cases. So here we have a little Pandas on Spark query, and at the end of it, we're invoking this toPandas function, which is going to convert to a Pandas data frame. Now, this is really nice because we can do the heavy lifting with Pandas on Spark, reduce the data set, and then once it's a smaller data set, we can convert to Pandas. And because it's smaller, we can actually fit it in memory, no problem. So we can see that this query is actually running on that same 7.1 billion row data set, and we're able to execute it in 13 seconds, no problem, and then convert it to a Pandas data frame. Let's take a look at how we might use this design pattern in a production setting. So let's suppose we have like a big 10 terabyte data set, and we want to kind of winnow it down, do some data munging, some data cleaning, some aggregations, and make it to like a 50 gig data set. Once we have that 50 gig data set, we want to use Pandas and XGBoost to train a model. Now, of course, we could just use some sort of distributed machine learning framework, but let's suppose we're very familiar with Pandas and XGBoost. Those are the technologies we're comfortable with, and that's just what we want to use to train our model. So in this case, we can take our big 10 terabyte data set and do the data munging with Pandas on Spark with the familiar Pandas syntax we like. And then once we have the 50 gig data set, we can just convert it to a Pandas data frame and then use Pandas and XGBoost to train our model. So it's a great example of a production use case for this technology, and also a great use case if you're very familiar with Pandas. Great. Let's recap the advantages of Pandas on Spark. We have this wonderful familiar syntax for Pandas coders. We have potentially faster query speeds for single node analyses, especially if the data set's on the large side. We have the ability to query large data sets and also out of memory data sets, right? Pandas, when it executes a query, it has to first load all the data into memory. So that means that if it's a larger than memory data set, you can't use Pandas, but Spark you can. And like we've seen, we have great interop with Pandas. It's easy to go from Pandas on Spark to Pandas and vice versa. So that provides a really comfortable experience for Pandas programmers to provide a variety of analyses and use the tools they're familiar with. Cool. I'm going to pass it on to Shinrong, and she's going to chat about how this all works.
Thank you. Yeah, thanks, Matthew, for the great introduction of Pandas on Spark. Now we are going to see how does it work. So Pandas on Spark is backed by Spark SQL and operates on top of Spark Core. And at the core of Spark SQL is Catalyst Optimizer. In the following slides, we'll see how it can help optimize your query plan and ensures a better performance. So focusing on Pandas on Spark, and when we say Spark SQL in the Python context, we refer to PySpark. And Pandas on Spark relies on PySpark, like more specifically the data frame API of PySpark. Pandas on Spark and PySpark both have data frames. In the next slide, we will see their difference and how An internal frame can fill in the gap. So here is a comparison between Pandas on Spark frame and the PySpark frame. So a Pandas on Spark frame mimics a Pandas frame, and a PySpark frame aligns more with like a relation or table. And Pandas on Spark frame has both rows and column identifiers following Pandas. But a PySpark frame has only column identifier. And Pandas on Spark is mutable, but PySpark has immutable data frame. But both Pandas on Spark and PySpark leverage the execution engine of Spark SQLs, including the catalyst optimizer we mentioned earlier. Now let's focus on the internal frame. So like internal frame, it acts like a bridge, connects both Pandas on Spark frame and the PySpark frame. And it holds essential metadata like the PySpark columns and names and data types of index and data columns. So here index refer to the row identifiers on a Pandas or Pandas on Spark frame. Since this concept is missing in PySpark frame, so we have to mark like which columns are corresponding to the index column. And here is like how internal frame works in between Pandas on Spark frame and PySpark frame. And when an API call happens against a Pandas on Spark frame, we can see that like the internal frame will be copied with new state. And in this figure, the PySpark data frame doesn't have to change. But in some API calls, the PySpark data frame can be modified accordingly. That's about like internal frame and how it fills the gap between Pandas on Spark frame and PySpark frame. Now let's shift our focus to like back to Spark SQL, especially the catalyst optimizer. So like we just talked about the data frame API, but in Spark SQL, like whether it's a SQL query or a data frame API call, they will be all converted to query plan. And this query plan will be like, we'll go through several stages of optimization. So first, it is the analysis stage. So basically, it understands your query plan. And secondly, it's called like logical planning. And then the physical planning. A physical plan is the executable plan. And finally, is the code generation stage, basically like generates code for cluster to run. And the catalyst optimizer is actually to abstract your query plan as a tree and then applying different rules to manipulate your tree nodes and to achieve a better performance. So in the following slides, we will see different rules, like optimization rules that are utilized in both logical planning stage and the physical planning stage. So first is the logical optimization. The first rule I want to share is about like column pruning. It enables to read the necessary columns only. So here's an example. There's a table of 5 columns, A, B, C, D, E. And then we have a filter against column C, and finally aggregation on column A, and get the sum of column B of each group. We can see that only 3 columns, A, B, C, are actively used in your query. So Spark will inject a projection before the filter, and that can actually enable an efficient scan because it will only read the necessary columns to ensure a better overall performance. That's the so-called column pruning. And the next rule we want to look at is called predicate pushdown. So it will push the filtering down to the data source. Here is an example. So let's say we have a Parquet file, and we read a table from the Parquet file has 2 columns A and B. and we apply a filter and then get the sum of both column A and B. And the predicate push down will push your filtering near to the data source. So in that case, it can leverage the chunk details of your Parquet file. And here, chunk details refer to the minimum and maximum value of each data chunk. And by using that details, it can skip unnecessary chunks. In that case, like make your query more efficient. That's the tool rules about logical planning. Now we will focus on physical planning. So here is a query. In that query, we join like table A and B. The join key is it's called key. And then we have a filter against column B1, grouped by A1, and the final output will be A1 column and B1, the sum of B1 of each group. So on the left-hand side, like in the plan in the green color is actually the logical plan, and it's already optimized by the rule we just introduced, like column pruning and predicate pushdown. And on the right-hand side is our physical plan. And we want to focus on the join part. So there are different join strategies in Spark, but here we choose the broadcast hash join. The reason why we choose that is because it analyzes the size of filter B, and it thinks it's small enough to be broadcasted. In that case, we don't need to shuffle A, and that optimizes the performance. So that's about physical planning. We just go through like different stages of Catalyst Optimizer and different rules that can help optimize your query plan. Now we will see how Pandas on Spark goes beyond Pandas. So like Pandas is more designed for data science and data analysis, but Spark is more about like unified analytics, which includes like ML, SQL, and streaming. So we support data frame conversion across 3 libraries like PySpark, Pandas, and Pandas on Spark. And on the graph, you can see like different conversion APIs. And especially when we, like a use case would be, you have a Pandas frame, and if you convert it to, Pandas on Spark by migrating to a bigger data set, then you convert to a Spark frame, then you have like all the functionalities like built with Spark. And secondly, Pandas on Spark enables you to query data via SQL. And that's enabled by an API called like SQL. In the example, we have a Pandas on Spark frame, and we call like ps.sql, and then you can query your data frame using SQL syntax. And third, we can also check execution plans. So one big difference between Pandas on Spark and Pandas is that Pandas on Spark is lazy evaluated. So you can actually predict the cost of your operation before actually executed. And this is enabled by an API called like dataframe.spark.explain. So in this example, let's assume we have 2 frames. One is called PSDF. The other one is a smaller frame called like PSDF_small. And we are doing the joining. And we want to see like the underlying query plan of your join. So here we call the dataframe.spark.explain API, and it will show the physical plan of your join data frame. And we can see that it's actually using the sort merge join here. But remember, when we talk about physical planning, there is a rule, there is a better, more optimized join, like broadcast hash join that applies to this scenario when you want to join a very big data frame with a small enough data frame. So we can actually give Spark a hint that this frame is small enough that we could apply the broadcast hash join. So here we can see that like when we do the drawing, so we call the Spark.hint API with the input broadcast, and then we call the explain API again. The plan actually changed. We use the broadcast hash join now. So that's about like the execution plan. Next, Pandas on Spark also enables you to leverage Spark's ML functionalities. So in the example, let's assume that you already have a model, and here you load the model. You load the model, and then you have your own like Pandas on Spark frame. You can, using your model, predict against the data frame, and that's your final result. So Pandas on Spark works with like major ML framework, work with like most ML models, like that includes like TensorFlow major framework. So lastly, we will talk about what's the like cool features in Spark 4.0. So first is the Pandas 2 support. So in Pandas 2.0 and 2.1, there are many like API breaking changes, which include like API removal, as well as its parameter removal and semantic change. And in Spark 4.0, we reached like the full API change parity with Pandas 2.2.2. And here is the Spark 0 ticket and migration guide if you are interested. I also like to share the current API coverage. So we have been working to improve our like API coverage. And so far by Spark 4.0, on major like data objects, for example, for data frame, we reached like 89% parity. And for series, it's 88%. And for index, it's 74%. And it's an ongoing effort. We're still trying to improve that. For those API that's not covered yet, we introduced a mechanism called fallback. That means it will like default to Pandas when you call those APIs on Pandas on Spark. So here is an example. Like as frequency, this API is not implemented in Pandas on Spark. So when you call this API, we actually have an error message like this method is not implemented yet. But now we introduce an option called compute.pandas fallback. If you enable this option, it will fall back to Pandas implementation of the as frequency. So now you can get the result. But also, you will have this warning because when we say fall back to Pandas, we actually load all data into the executor's memory. That means the input frame has to be very small. So that's all I wanted to share. So we have seen the internals of Pandas on Spark and like what's new in Spark 4.0. and how it goes beyond Pandas and to utilize Spark functionality. I hope that can help give you a deep understanding of Pandas on Spark capabilities. Thank you. Yeah, thanks, Matthew.